Okay, so a very good evening to all of our audience from Facebook and YouTube watching our live session. So again, we are from Astronomical Society of Penang, and as usual, on the every last Saturday of the month, we will have a special session to share the APOD, which is Astronomy Picture of the Day for the month. So today, we have four of us over here sharing the APOD for May. So let me have a simple introduction for all our panels today. So I'm Lai, and together with me we have Dr. Chong. Both of us appear every month, so you see our face every month. And today we also have Mr. Sunit Singh presenting with us. All right, Sunit is boys from just finished his SPM from Chongling High School and currently waiting for his results, for SPM results. And also he is very experienced. He joined the Astronomical in Chongling since Form 1. So he is practically and theoretically expert in astronomy. So if you have any questions, all right, feel free to ask him and he can give you the best answer. And we have a new member today presenting with us, which is Tri Jerchin from College Tuanku Jaffa, right, in Negeri Sembilan. So he's currently doing in his A-level, and he's also an expert in astronomy. In the year 2019, he followed Dr. Chong to Romania, representing Malaysia, joining the IAO, International Astronomy Olympiad, and he won the bronze medal. So he's also an expert. All right. So before we go to the APOD today, just a kind reminder to all of our audience in Facebook and YouTube. So if you all have any questions, feel free to type it in the comment section or the chat box. Is it? Yeah, the chat box on the YouTube channel and the comment section in the Facebook. So without wasting time, let's start with the APOD today. So first, let me share my screen. Okay, so today is 29th of May. We have the APOD today. So this is the APOD today. All right, let me first zoom out a bit, which is the lunar dust and duct tape. So before we go into duct tape, all right, so let's see, this is a historical photo, I'd say. Okay, because it's Apollo 17, which is a mission on the year 1972. Okay, so the Apollo 17 is the last crew lunar landing mission by the Americans. So it is launched on 7th of December 1972 using the Saturn V rocket. So over here, okay, the last crew mission, there are 3 crews, which is Eugene Cernan, Ronald Evans, and Harrison Smith. Okay, so this is they call it the, what do you call? They call it the LRV, Lunar Roving Vehicles. Okay, but this is not the first lunar roving vehicles. This is actually the last one. Before that, in Apollo 15, they already start the LRV. So this is it. So with this, there's some issue. Okay, from this APOD, we can see there's some issue on the fender of the rear wing. Sorry, not rear wing. Sorry, the rear wheel. So we know that the environment in the moon, all right, is very different from Earth. So let's have a look on the caption. So it did mention over here, all right, on the moon, the history of constant micrometeorite bombardment was blasted away at rocky surface, creating a layer of powdery lunar soil. So that means on the lunar surface, all right, the soil is very fine. So without this fender, when this rover move, all right, so it will have the dust tails. So the rooster tails of dust, okay, will cause damage or cause problems or cause issues to the system, the propulsion system, and even will affect the astronaut. So it's very important to repair the fender. But in moon, they don't have spare parts in moon. So what they can do is they have to do something that can temporarily solve the issue, which is using duct tape. And bear in mind, this duct tape is different from the duct tape you use in the bookshop or in the stationery shop. This duct tape is a special duct tape. All right, we call it a speed tape, or we call it a metallic duct tape. Okay, it's aerospace standard. All right. So if you realize over here, so in aircraft sometimes, if you are unlucky enough or you are lucky enough, you might be able to see some aircraft. They have this kind of tape. It's the same. It's the same standard. All right. Don't worry. This tape. All right. This speed tape is very special. All right. It's a aluminium pressure sensitive tape and can do minor repair, and it can withstand high UV, high temperature, and high moisture. So over there in the moon, over here, all right, so you can see the duct tape. So this is very special. It's not the common duct tape. So that's it for the Lunar, for the APOD today, sorry. So next, we move on to the APOD on 27th of May, which is 2 days ago. 2 days ago. So this APOD is, I think, is a lot of us, is a favorite of a lot of us in the Astronomical Society of Penang. I think 2 days back, our member Young Lip in Taiwan sent us this photo, and he mentioned that this is a 3-in-1 APOD. Why? The first one is a radio telescope over here, and then they have the lunar eclipse on Wednesday, which is 26th of May, a lunar eclipse, a total lunar eclipse, and also the Milky Way. So 3-in-1. So this image, all right, or this photo is captured by John Cross. John Cross is actually an American. He called himself a space flight photographer. So if you search on his profile, you will see a lot of space flight images, especially the rocket launch. It's fantastic. All right, so he's based in Florida. And let's go a bit details of this image. All right, so we have seen a lot of image. We have seen a lot of APODs on Milky Way. We have seen a lot of APODs of this lunar eclipse. But this lunar eclipse is the lunar eclipse on the most recent one, which is on Wednesday, the 2 days ago. All right. So how this image is taken is this. So he placed his camera on a fixed point, okay, which can see the moon, and then he start capturing. So over here, he did mention, all right, it combined. Over here, the frame taken every 5 minutes from the fixed camera follow the surrounding progression of the eclipse. So that means this is the first image, and then second image, 5 minutes later, the second image, and then the moon shifted here, and then over here. And you realize that there's a big gap. It seems like there's a big gap in the center over here, all right? Because this big gap over here is the totality. That means the moon is fully covered by the Earth's shadow. So over here is partial, over here is total, and over here. So this APOD is taken in this California, all right, with this Obrow, okay. Owens Valley Radio Telescope. Owens Valley Radio Observatory is owned by Caltech. All right. So this is a 40-meter dish, 40-meter radio dish, and it's located in. You can see this. All right. You can see this if you are driving on the highway in the United States. So this telescope is located not at sea level. It's 1,222 meters above sea level. Okay, so this is it about the total lunar eclipse. So just a little bit information on total lunar eclipses. So after this total lunar eclipse, next total lunar eclipse will be on next year. All right, will be on next year, somewhere in May. And next year there are two total lunar eclipses. One is in May, one is in December. All right, and when it is nearer, we will announce whether it is visible from Malaysia or not. So to know whether it's visible in Malaysia or not, you can actually look on the visibility map. All right. Oh, I don't have it over here, but then you can see which region cannot see. Like for this time, in the Europe side, they cannot see the total lunar eclipse, but in Asia over here and in American, they can see that. For us, is during the moonrise, and in America, is during the moonset, so we can know. So this part is the west, okay, and moon is setting. So just a little bit to share a little bit more. So this is the image taken by our member Yong Lip from Taiwan on the total lunar eclipse. And another one is from Emma, Dark Sky Malaysia, taken by Lukmano Hakim. All right, it's also a total lunar eclipse taken in this Sabah, Lahad Datu Sabah. So next, we move on to 24th. All right, 24th of May is also on lunar eclipse taken by Chris Kotsiopoulos. All right, it's a great landscape photographer. And the interesting thing on this is the lightning. Okay, the lightning. So this is the lunar eclipse on 2011, which is 10 years ago. 10 years ago in Greek, in an island called Ikaria Island in Greek. Okay, so before we discuss about this Ikaria Island, so this is a partial cloudy weather, as you can see, partial cloudy weather, you have clouds, and it just opened up for, in the caption it mentioned that it opened up for 10 minutes and they can see the total eclipse. So almost they miss the eclipse if it's cloudy. So this condition is actually quite similar to us in Malaysia when observing. I remember in 2019, January, there's also a total lunar eclipse where we are observing from Kapasing Drive, and the weather is almost the same. It's partial cloudy. So at the moonrise, it's a bit cloudy, we cannot see, and then it suddenly open up for like 15 minutes, and then cloudy again, and then open up again. So this is the experience of astronomer, especially in the tropical area. And another thing is, total lunar eclipse with lightning is very rare. Photos like this is very rare. So lightning is a very common natural phenomenon in Earth, okay? And even in other planets like Mars, like Jupiter, like Saturn, there are also lightning. Okay? Usually, the planets with thick atmosphere or with atmosphere, then you can have lightning. So how lightning is formed is actually there are highly charged region, okay, and it suddenly discharge, instantaneous discharge, okay, and it will give out a very huge amount of energy, which can go up to a few gigajoules. All right, so this a little bit more about this APOD is taken in Ikaria Island, so it's in Greek. All right, it's a very beautiful island, but then it's over here. All right, it's very near to Turkey. It's in Ikaria Island. Okay, it's an island, so we have beautiful scenes. But because it's a lunar eclipse, it happens at night, so you can't see the beautiful scenery over here. So the last APOD for me is this on 23rd May. Okay, 23rd May. So on 23rd May over here, let's see. This is, the title is called the Galaxy Tree. So you have the galaxy, there's a galaxy over here, and then we can see the constellation, and we can see a tree, a silhouette tree. So this image is by Cesar Vega Toledano. It's a Spanish landscape photographer. And the row word annotation, that means all these blue lines, these lines annotation is by Judy Smith. So this is taken in a town called Salamanca in Spain. Okay, so over here we have, right, this is the actual image, okay, the actual photo. We have the Milky Way, and then we have the constellation. So a little bit information on this is, from this image, okay, with the constellation, we can know actually where is this image facing. That means where is the camera facing, and also knowing the geographical location, and with the hint given over here, which is it says that the photographer stay up until 2 a.m. waiting the Milky Way galaxy to rise above the level of majestic looking up. So that means this photo is taken at 2 a.m. So even though it didn't mention when it is taken, it just mentioned that it's a 30 seconds frame in 2015 and processed digitally. So you can actually get the information from all this constellation. Is this photo, all right? This APOD is facing east, and the period of this image taking. So we see we have Sagittarius over here. We have Pegasus rising. So eventually this is east, and it will move from this corner to up to this corner. So the path will be like this, somewhere like this. All right. And this is taken around, okay, with all this information, you can take a guess is around May, around this time, all right, around 20 to 25th of May, all right, using all this information. And over here, there's a nebula called the Lagoon Nebula. So this Lagoon Nebula, or we call it Messier 8, okay, or call it NGC, New General Catalog 6523, is located in the constellation of Sagittarius. All right, so we can have a look on this. This is the Lagoon Nebula. All right, and it's it's quite near, 4,000 to 6,000 light years away from Earth, and the span is about, from here to here is about 100 light years, 110 light years, and the height, okay, from bottom to top over here is about 50 light years. So that's it about me. That's it for me for the APOD today. So next, I'll pass over to Jachin for the next APOD. Right.
Okay. Thank you, Lai. So, right. So, can you guys see my screen?
Yes.
Yes.
So, first of all, I'm gonna show about the May 22nd picture, which is the Macarian chain. So if you see the picture here, there's a lot of galaxies in the picture. And this is actually a famous strip in the Virgo constellation called the Virgo supercluster. And if you look at, even using your telescope, if you look at that part of the Virgo constellation, you can see a lot of galaxies, deep sky objects in that area. And the reason behind it is because that area is the direction of the Virgo, the center of the Virgo supercluster. Okay, so the special thing about this picture is that if you look from this this galaxy here up here, it sort of resembles a chain, and in fact, this is called the Macarian chain, and because the astronomer Macarian, he found out that around 6 of these galaxies in the chain, they have the same direction of movement. And this is not really surprising because they are actually belong to the same galaxy cluster. But it also reminds us of the scale of the universe, because all of these deep sky objects are actually galaxies of their own in a very far away distance, because all of these are at a distance of around 54 million light years away. And at that distance, right, the light coming from you is 54 million years ago, which is, on Earth, it was like the Pleistocene era, which is the era when the dinosaurs went extinct. So yeah, actually you're peering back into the history when you look at the Macarian chain in the Virgo constellation. Okay, so next we have the May 21st Utopia on Mars. Yeah, so actually this is an old photo. This is not a new photo. This is taken in 1976 during the Viking lander mission. And the area here is called the Utopia Planitia. You can loosely translate it into the land of the paradise. And the reason behind it is that this patch of land on Mars is a land of interest to the scientists because it is the largest crater in the solar system, not on Mars, but in the solar system. So during the Viking program, they sent a lander to there because there's a lot of scientific interest on this patch of land. The minerals is, instead of hiding deep inside the ground, they get evaporated closer to the surface. And that's the reason that the Viking program send their landers here. And the reason it's chose as the astronomy picture of the day is that at this date, the Chinese Zhurong rover landed at the same place, Utopia Planitia, as part of their Tianwen 1号mission. And if you look at the photo, these are actually trenches dug up by the Viking rover to do soil sample analysis. And this is actually a protector for the soil collector. And yeah, this is part of the rover. So you can see there's dust on it. So yeah. And now we're going to move on to the 5th of May. Okay, this is a nice, very nice picture, my personal favorite. Very big one. So, okay, so try to guess what type of phenomena is this. Okay. Okay, so this phenomena is not an aurora. It's actually a different phenomena called a STEVE, which is it stands for strong thermal emission velocity enhancement. It's actually a acronym called STEVE. And you know that aurora is actually caused by the disturbance in the magnetosphere when the solar winds cause the electrons and the charged particles to precipitate in the upper atmosphere. That is how aurora is formed, when the charged particles it's called the STEVE. So there's the charged particles, they decelerate in the upper atmosphere and then they give out the EM radiation. And that explains aurora. But STEVE has a totally different mechanism. But the exact mechanism still remains an active topic of research. But what we know now is that they hypothesize it's because of a hot river flow of ions in the upper atmosphere. Not exactly in the magnetosphere, but lower down in the atmosphere. There's a stream of ions flowing in the atmosphere that cause the purple or pink. Usually you will get accompanied by, and in fact you can look, you can see some of these pictures got STEVE in them, and not this. Yeah. So usually the STEVE will get accompanied by this green picket fence, but it still remain a topic of interest. So if either you guys want to do some astronomical research, this is a very good topic of research, I think. And that concludes my session. So I'm going to pass it back to Dr. Chong.
Yeah. Thank you very much, Justin. Okay.
Dr. Chong, before you start, sorry, if you don't mind, I leak a bit. So this Steve zodiacal light aurora is important topic and might come out in the primary school quiz this year. So if you are interested, can play back to our Justin's presentation on this Steve again and then make some notes. All right, some tips from me. All right. Okay. All right. So Dr. Chong, please. Thank you.
Thank you again. Okay, so can you please unshare, Justin? Thank you. Just be patient. Can you see my screen? Right, can you see my screen?
Yes.
Okay. So mine is on the 2021, May 19. Jellyfish and Mars. Ladies and gentlemen, boys and girls, that is why I like APOD. Because APOD is a mixture of all kinds of pictures, not only by astronomers and all kinds. So we see here, 2021, May 19, all right, the Jellyfish and Mars by our Jason Gwenzel. So he's an amateur astronomer from the state of Michigan in USA. So basically, you see here, look like what? Oh, this is what they call Jellyfish Nebula. And they also have another name, IC443. So in astronomy, IC means index catalog. All right. The index catalog is an addition to the earlier catalog called the NGC, New General Catalog. And here you have the, what we call this, the jellyfish. Here's a Mars. And of course, this is in the, what we call that part of the sky. Geminorum. And far to the left, on the left is the star Castor in what you call in Gemini. So basically, this is what now this is found to be a type 2 supernova explosion. That means many years ago, a red supergiant star exploded, and the shock wave is still expanding. Now, mind you, it's very big. The width of this what you call jellyfish is about 70 light years, or about in space is about not very far from the Earth. It's about 50 arc-minute. Remember, the diameter of the angular diameter of the moon as seen from the Earth is 30 arc-minute. So this is bigger than the size of the moon. So this is fantastic. So you see a lot of things here. So basically, what is a supernova? Is a red giant star like Betelgeuse in Orion is surviving for many years, hundreds of millions of years. And all of a sudden, in a split second, it will implode and explode. And the power of the explosion is such that it blows the star to bits. So that light will shine in the few months of the explosion, outshine all the stars in the whole galaxy. All right. And at the moment of explosion of supernova, what is a material blown off? You surprise neutrino. At the moment of explosion, 99% of the particles energy given off is in the form of neutrinos, and the rest of course proton, neutrons, and so on. So this is our what we call jellyfish nebula. Okay. So this one is very beautiful. All right. So you see here an object very far away, and here is Mars. And at that time, Mars in May is about 18 minutes light minutes away. All right. The next picture, 17. May 17, which is Galaxy on Edge, NGC 4565, all right, new general catalog. And some will say, okay, I'll make it smaller now. Okay, you may say, so what now? This surprisingly is similar to our Milky Way, all right? So according to the astronomers, they have done some research. We are looking at this great spiral galaxy H on. So you see H on, you see the, make it smaller again. You see the bounds of the galaxy where most of the stars are located, and then you have the plane of the what you call the galaxy, and you have the dust rain, right? So it seems that this is similar to the Milky Way, right? And it could be a bar spiral. A big telescope were built in Chile. These were the biggest collection of telescopes in the world in Hawaii. See that? And Column is one of the Italian astronomy magazine. So the big wide angle camera on Canada France Hawaii telescope is a mega cam, all right? And this picture was taken by a French astronomer, Monsieur, what we call Jean-Charles Pillon from France, but he was working in the telescope, and by this Giovanni Anselmi. Giovanni Anselmi is the founder of the Italian astronomy magazine Column. So this is beautiful. So this is actually a grand astronomy magazine Column. So this is beautiful. So this is actually a grand spiral galaxy. Hey, in the background, another galaxy. So many galaxies, right? So this is the wonders of the universe, all right? So now when we look at a picture of a galaxy, we don't see that it's so beautiful. So I always like to add on that, sorry, this is only 5% of the universe, meaning this is so-called the what you call the ordinary matter makes up 5% of the universe. Another 27% is the dark matter, which we don't know yet, we don't see. Another 68% is the dark energy, which we don't know yet and we don't see. So whatever we see in the telescope, of your eye when you look at the sky, the stars, the galaxy nebula is only 5% of the universe. So there's somewhere in this picture there is dark matter, and somewhere in this picture you have dark energy. All right. So we go to the next picture, 13. This is a strange picture. Enlarge it so that you can read it. So May 13. Wow, what is this? All right. The comet, the whale, and the hockey stick. Now that's why I like about astronomy. So welcome to the astronomical zoo or the zooniverse, because the astronomers like to give nice names to this object, like Eskimo Nebula, Horsehead Nebula, all kinds of interesting names. And not only what they call animals, but also hockey stick. So this is welcome to the sports zoo. Right. So basically here you have our this is taken from our Grand Mesa Observatory by these two Masari. Terry Hancock is originally from England, migrated to Australia, then went to America, and now took from this observatory called Grand Mesa Observatory in Colorado, all right, next to the city of Boulder, Colorado. And there's another amateur astronomer, Tom Masterson from Los Angeles. They went to that observatory in Colorado and took this picture. So you have Comet Atlas here, all right. One of the recent comet, and many of the comet you have the green light. So green light is our diatomic carbon. So remember, what is a comet nucleus? It's a frozen ices. So as the solar energy falls onto the on nucleus of comet, you evaporate, and you have this diatomic carbon. Diatomic carbon means two carbon atoms attached to each other by a covalent bond. So when the diatomic carbon has sunlight fall on it, it will excite it and it will emit a series of lines on fluorescence in the green light region. So that's why it's green color. All right. And here you have this, the whale. They are not clear, and they call it hockey stick. So they enlarge it. You see better the whale. Some more. This becomes smaller. So this is the whale, and this is the hockey stick. Right. So according to the astronomers, they already know that this is a pair of interacting galaxies. Interacting in the sense that the gravity of this whale and this hockey stick are affecting each other, right? And that's why it's called band, right? So in fact now, in many of the pictures we are presented, many of the galaxies we take pictures from the Earth, they're interacting with previous galaxy. So what happened is these two galaxies have interacted much earlier, and they look distorted, right? And this is the whale, the hockey stick, and the comet. All right. Now I pass over to Sunit. Sunit, you're on. I unshare.
Okay, can you see me?
Yes, I can see now. You're on, Sunit.
All right. So, hello, good evening to everyone. So today I'll present the APOD for 12th of May first. All right. So the picture called a meteor and a Gegenschein. Yeah. Make it bigger. Meteor and a Gegenschein. So first of all, from the title we can see that Gegenschein. What's this? This is quite a very strange word to us. So actually, a Gegenschein is this. You can see there's a faint light in the night sky. So Gegenschein is actually when there's a bright spot in the night sky where it's centered at anti-solar point. So I'll elaborate more. It's actually also known as the counter glow, where when you're facing 180 degrees towards the sun, away from the sun. So let you see an example of the Gegenschein. So as you can see, when the sun hits directly to this tripod, you can see around the tripod is much more brighter. The shadow around next to the shadow, there's a bright spot, and away more further to the shadow is a bit faint. So Gegenschein is when it occurs when the dust particles in the solar system or space debris, it reflects the light of the sun. So you can see there's a faint light produced over here. And apart from that, from this image, it was taken at the Tenerife island which is at the western of Africa. Yeah, and you can see the Mount Tate, which is the highest point of Spain, and there's a meteor over here. So the photographer J.C. Casado, oh, sorry, J.C. Casado, or you can say Juan Carlos Casado is a astrophotographer from Spain, and Starry Earth is a group from an online website called Flickr, and EE Labs is actually a project financed by the Interact VA Mart 2014 to 2020 program. So basically, this program is just to run some projects. Yeah, and Tuan is the world at night, TWAN. Yeah. So in this picture, we can also see that there's a big tipper over here, and if we see towards these two pointer stars, and then we can also see that Polaris over here with these two stars. And not only just Big Dipper is over here and Polaris, we can also see there's actually a lot more constellation in the background. So let's just see briefly. Yeah, this is actually all the total constellation in this picture. There's a total of 16 constellations. Okay. So now I'll move on to the next APOD. All right. So the APOD for 11th of May, Lightning and Orion beyond Uluru. Okay, so this picture, Lightning and Orion beyond Uluru, is taken by Park Liu. He's a astrophotographer from Australia, and what you can see is that Uluru is actually this rock over here. Now, this rock is actually formed about 300 million years ago, when there's actually the rocks. Sorry, it okay. This was formed actually when the sand and mud. First of all, the sand and mud covered this whole thing, and before this, about 500 million years ago, this whole thing is actually sea. There's no land over here. And then about 300 million years ago, where the sea disappeared, the more soft rocks and the rocks and stones, they actually just eroded away, and they leave only this big rock over here. Now you don't see that Uluru is actually this small, but it's like an iceberg. You know that iceberg, when you see it above the surface, you can see it's actually quite small, but below the surface, actually Uluru, this rock is very, very big, and it can go underground as far as 6 kilometers. Okay, and okay, in this picture we can also see that there's lightning over here, but we can get clear skies over here. Now we can see Orion over here, and there's some star trails. Actually, sorry, not star trails. These are actually maybe airplanes just fly by during this picture is taken. Okay, and about this lightning, actually, about 22,000 years ago, when there's the peoples living right here at here before the European come to Australia, the local people, they used to observe the Orion constellation, and when they see that the Orion constellation is on the sky, they know that actually the lightning season is going to come. So that's actually a quite interesting fact for this lah. Okay. So about this sky, there's also a lot of constellation in this picture. It's about 9 of them. Okay. So I'll move on to the next APOD. The 10th of May. All right. So this APOD, this picture, star cluster M35 at NGC 2158, the Messier catalog and the New General catalog. Okay. Okay, so this is the whole picture. It's actually quite big. Okay, so first of all, we can see M35 is actually this over here, and this over here is NGC 2158. Now, N35 appears to be blue because all these stars are actually quite young, and NGC 2158, all the stars in that cluster is quite old because you can see that it's quite yellowish, means that the lifespan of star is quite longer compared to the blue stars over here. Okay, so this picture is taken by the CFHT, the Canada France Hawaiian Telescope, the Colium, the Italian website which publish magazines Megacam, JC Puilandre, and GAN Selmi, which just now Dr. Chong have already mentioned. Okay, now this picture you can see all these stars in F-35 is actually about 3,000 light years away from us, and the stars over here are actually 4 times more further away from us, which is about more than 10,000 light years away. Okay, so these two objects is also located at the constellation of Gemini, and it's discovered by oh sorry. Okay, so I'll move on to the next APOD. Okay, so the APOD of 8th of May, which has the title of Deepscape at Yakoret. Now this picture is taken at Yakoret, which is at northwestern of Argentina, and was taken by Franco Macconi, which is a astrophotographer from Argentina. Okay, so in this picture we can see there's a bright spot over here, and this over here is actually Antares, which is the a star in the constellation of Scorpio. And you can see there's actually a reflection nebula around the star Antares. And it's not just any ordinary reflection nebula, it's a yellowish reflection nebula, and it's quite unusual in astronomy. Now, usually reflection nebula are quite more blue in color because light scattered more efficiently in blue light. It's the same thing like blue sky. When we look at the sky, it's all blue because blue is the blue light scattered is more efficient. Okay, and this picture actually consists of 2 separate images. So the photographer himself, he took a picture for the sky first, and he used a very, very long exposure to take the sky. So if he used the same exposure, if he took the image together with the ground and the sky, because he have to use a very long exposure, it means that it will cause the picture to be quite blurry, as the ground will actually interfere with the sky, and so the picture will be very blurry. So the photographer itself took a very long exposure for the sky, and he also separately took another picture for the ground. Okay, so that's it for me. I'll move on to Dr. Chong.
Thank you very much, Sunyi. Fourth of May. Okay. That is why I like APOD pictures. Because APOD pictures is not only nebula galaxy. It can come from anything, right? So we make it a bit smaller. So May the 4th, all right? Space station, which means International Space Station, solar prominence, and the sun. So this is the space station. This is the solar prominence, and this is the sun. Okay, taken by our Mr. Mehmet Ergun. Of course, he was born in Turkey, but he grew up in Germany, right? So basically, You see, previously, many years ago, I followed the airport picture. They will tell you what camera he used, which location. Now, no. Now they assume that the people who see airport pictures are good enough to understand it. You need not say that it's taken by what telescope. So that means that there's a certain telescope. He took it somewhere in Germany and he took it. All right. And of course, this picture shows that what is in the hydrogen alpha wavelength. Hydrogen alpha wavelength is somewhere in the hydrogen alpha line, about 600 nanometer in the red region. So basically, to take this picture of the transit of the ISS across the disk of the sun, he had to take 3 pictures, right? So sometimes when you look at the picture, you ask yourself, how come I try to take picture like this, I cannot take? But from reading what's down there, he took it with 3 techniques. One is he took a first shot, you take a longer shot so that the prominence is overexposed longer time. Then the prominence can be seen. That's the first exposure. The second exposure, you took a fast exposure. Fast exposure, you cannot see the prominence, but you can see this part. This bright part is called the chromosphere. Remember, the sun has a surface called, not a solid surface, a hot surface, called the photosphere. Above the photosphere is the chromosphere. So I repeat, the prominence was long exposure, first shot, second shot, with the same camera, second shot, faster exposure to see the chromosphere. And the third one was even faster, so that he snapped his camera very fast. Then you can see the ISS crossing the disk of the sun. Remember, the ISS is about 300 to 400 kilometers from the Earth's surface and travels around the Earth at 8 kilometers per second. So basically, at that speed, the ISS can cross the full diameter of the sun in less than half a second. So he must be very accurate. So he took a fast shot, you can see it. Now, in fact, you can even see that the Crew Dragon, this is an enlarged picture here. I try and see I can enlarge it even bigger. The Crew Dragon on the upper, okay, there you are. Now you see here the Crew Dragon spacecraft, where they send the 4 astronauts by SpaceX to go to ISS, is attached to the ISS. So here is not enlarged, but it is somewhere here. Crew Dragon, you can see. So in other words, now you know, if somewhere on the Earth's surface there's a building 400 kilometers away from you, with a good telescope, you can see like that. Okay, so this is our ISS transiting the sun solar disk. All right. So the next one would be May the 3rd. Now this again related to what Lai said earlier about the Apollo mission. So I really like it. I remember in the year 1969, if you don't mind my personal story, I was studying in school in KL when the Apollo 11 astronaut landed on the moon with this, this is the ascent stage of the lunar lander. The descent stage landed with ascent stage, and Neil Armstrong and Buzz Aldrin walked on the moon. That time it was my secondary school in KL in the 1960s, 10 a.m. So I came out, I told myself, they have landed. But sorry, at that time in Malaysia, 1969, don't have live broadcast. So that evening, we saw the delayed broadcast. And in 1969, television in Malaysia is still black and white. So we saw that the Apollo mission landed on the moon, black and white. And then Neil Armstrong walked on the moon, Buzz Aldrin. And President Nixon talked to the 2 astronauts. So basically now, after the mission on the moon, so the mission was from 16th of July to 24th of July, 1969. So on 20th of July, landed on the moon. So after landing on the moon successfully, the ascent stage blast off from the moon and go and join up with this capsule here. But the 3rd astronaut did not land on the moon, Michael Collins. So we heard recently that Michael Collins just passed away. So you have Neil Armstrong, Buzz Aldrin in the ascent stage, leaving the moon surface to join here. And here you have the rising Earth. So when we saw this picture, it was great, So basically, this is taken by NASA, of course, but it's restored. Now, this guy, interesting story. Toby Ord is an Australian philosopher. First time I saw a contributor to APOD is a philosopher, and he has a website called Earth Restored. So all the old pictures in the space exploration, he will touch them out, restore them. So this is by Toby Ord, philosopher. And so this one will join with our what do you call this command module or Apollo 11 and go back to the Earth. Now remember, there's a nice comment here below. It says that this iconic image says that every person but one was in front of the camera. So now the person took it is Michael Collins, not in the picture, but Neil Armstrong and Buzz Aldrin is here, and the rest of humanity is behind. So this is the whole of humanity minus one. All right, the Earth's there, all the people there, the two astronauts minus Michael Collins. So this is very nice. And remember, until today, how many of the human beings have seen this picture of the Earth? It is 24. Remember, altogether, each Apollo mission got 3 astronauts, American astronauts. There are 8 American Apollo missions that travel from the Earth to the Moon and back, and they could see the Earth like that. All right, but not all the Apollo mission landed on the Moon. There were 2 did not land on the Moon. All right, Apollo 13 because there was an accident, did not land on the Moon, and then Apollo 8. Apollo 8 was the first Apollo spacecraft to circle the Moon, but did not land on the Earth. But circle the Moon and go back. All right, it was only Apollo 11. So this view of the Earth as seen from the Moon have been seen by 24 human beings, the American astronaut. All right, very interesting. So we go to the next one. May the 2nd. Now this is, I really like this picture. I have a feeling. So what is this? May the 2nd. Clouds of the Carina Nebula by John Ebersole. So basically, John Ebersole is a retired neurology professor in the University of Chicago. Well, what's your neurologist? He's the one who studied the brain of human being. So you need not be astronomer to be an astrophotographer. So he is actually a retired neurology professor, expert on the brain, and he took this picture. And again, they never explain what equipment he used, but that one we assume that we already know, right? And look at the detail. That means very good tracking. And what is interesting about this Eta Carina Nebula is in the constellation of Eta Carina, right? And Eta Carina is in the southern sky. You see all these dark molecular clouds, all right? And so here you have different types. I can see here immediately the 3 types of nebula. You have the dark absorption nebula, and somewhere here, you see the star here is giving off light, and it excites the atoms in the space here to give off light. Emission nebula. And there's another one here. The light is given off a star, hit the cloud, reflected off. Reflection nebula. So the 3 types of nebula are seen here. Absorption nebula, reflection nebula, right? And then emission nebula. So very interesting. So now we know that the astronomers have seen a lot of cases of this type of nebula in space, that this is what is called what? A stellar nursery. Or in Malaysia, we will call it what? Tadika Bintang. This is where new stars are going to be born. Now, this could be many light years across, So maybe thousands of new stars will be already. Some already are being born already. So new stars are being born, and of course, in the new stars, what maybe got future aliens, right? So basically, now, so this type of clouds of gas and dust were emitted by the earlier generations of stars that died, and given a long enough time, gravity will make them collapse, and new stars will be born. And we're surprised that from this cloud of gas and dust, only 1% of the gas and dust will be able to collapse to form new stars. So the 99% of the gas and dust is wasted. So why? Imagine somewhere here, there's a dark absorption nebula, and then a star is born. So it emits very powerful stellar wind, much more powerful than our sun's solar wind, and it will evaporate the nebula. So only a small part of it successfully to form the star. 99% is gone, wasted, right? That's what it is. So I end it now. So maybe I will also add on for our this Astronomical Society of Penang. We also are promoting our products. So this is our Shopee. You can go in, you can have a look. So it's our T-shirt here, right? I love astronomy unisex round neck full cotton shirt. Looks like that, different sizes. All right. I think one if you order through Shopee is 25 ringgit. The next one is Lazada. our astronomical calendar 2021. Every year, our society ASP conduct the astrophotography contest. So this is the winners of 2020 contest. The 12 every month got one picture. Also on Shopee, this one. So so every what they call year. So the winners of 2020, you turn to Canada. Wow, like this, all right? So each one, this one I check is on Lazada is for 20 ringgit, all right? So if you want to buy in bulk, you can check with us also. We can show you. So this is the entry for January, all right? So we thank our society treasurer Michael Teo, who what we call handled and organized this contest. Very nice. So this is where great. This is astrophotography, right? This is our great Orion Nebula, the Running Man, and this is not taken from Hawaii, not taken from the Sahara Desert, by a Malaysian from Malaysia in our astrophotography contest, right? So you're welcome to join our event in future. So in our coming weeks, we have all kinds of events. So next week, we are going to interview another Malaysian amateur astronomer, Mr. Ponky. And 2 weeks from now, we are going to interview 5 of the Malaysian students. They went to the International Astronomy Olympiad 2019 in Romania. And Justin is one of them. So Justin will give his own personal story. Oh, what date the IAO? 12, huh? Okay. So on the 12th of August, of what they call June, we are interviewing 5 Malaysian students, right, including Joaquin. So Joaquin will give us his personal story, how to prepare for the what they call the very rush, the Olympiad, the good experience for him and all of us who went to Romania. All right. So thank you very much for watching. All right. So any question, Michael, for us? No, huh? Okay, never mind. So you want to check out now, and afterwards we have our own discussion.
So can follow our Instagram, Facebook page, or this lah. Yes.
Yeah, right. Okay, I'll answer.
So this is our Facebook page, our Instagram, and also our YouTube channel. So do subscribe to us to follow or to enjoy the universe or to learn more about astronomy. So that's it from me. And thank you, everyone, and have a nice night. So we see you next month.
No, 2 weeks from now. Next
I mean the APOD, this APOD session next month, end of next month. And of course we have many other activities, many other interesting activities as well. So thank you, Dr. Chong. Thank you, Sunit. Thank you, Justin. And have a nice night.
Bye-bye.
Bye-bye.
Yeah.